Good morning, afternoon, everybody. Thank you for joining us here for today's live webinar, where we're going to be looking at something I'm particularly interested in. Now, my name is Dean Pearson. I am an application engineer, and most of my time is spent assisting our customers learning to effectively use the FARO Zone 3D software. Today, I've been asked to put on my moderator hat, and I'm very pleased to do so because, as I say, this is a subject matter that I'm very interested in. Obviously, you are as well. What are we talking about today? Well, we're going to be looking at best practices for public safety and forensic 3D scanning today. Over the course of the next hour, we're going to pull back the curtain a little bit for you, give you some insights into how real experts in the field are doing it. And we are very pleased to have a very experienced presenter for today's presentation. Her name is Brenda Butler. Now, Brenda's official title with FARO is sales engineer, but as you're going to see in a moment or two, when you see her bona fides, you'll know that sales engineer really doesn't fully encapsulate her length and breadth of experience in this field. I'm really excited to hear what she has to say because you'll see, among other things, germane credentials to today's conversation for Brenda include 20+ years of law enforcement experience. She's processed well over 200 crime scenes. So when it comes to the meat of the matter about getting your work done in a more expeditious manner and increasing your quality as well, I honestly can't think of another FARO professional that we would be better suited to have hosting us here today. It's my pleasure, ladies and gentlemen, to present to you today's presenter, one of my colleagues at FARO Technologies, Brenda Butler. Brenda, the stage is yours.
Good afternoon, everybody. Welcome, and thank you for that wonderful introduction, Dean. I want to cover with you a little bit of what we're going to do today. Our agenda today is to work through the best practices when it comes to scanning. So what we do today will be focused on your scanner and not on the software. If you do have questions about the software and that you want to ask, I'll be happy to address them through email at a later date. You also can email me at brenda.butler@faro.com anytime you have a question that you need to get answered. But for today's agenda, we want to focus on the scanner itself, the fundamentals to scanning and how great the product is that we turn out for our preservation of our scenes of our courtroom is based on these fundamentals. So we're going to talk about creating a plan, and we're going to talk about how to place the scanner. How do we know where our scanner is supposed to go? When do we use threshold scans? We also want to talk about scanning bodies of vehicles and hidden objects. What about scanning indoors versus scanning outdoors, or maybe when the lighting conditions aren't nearly as good as we would like them to be? We're going to address adaptive scanning and high-detailed scanning, and we also are going to talk about documenting bullet impacts and bloodstain patterns. And of course, we are going to have our question and answer sessions that Dean already mentioned. A little bit about my experience in education. I started out in a police agency in a small city in Ohio. I worked there for over 13 years before going to the Ohio Bureau of Criminal Investigation for 7 years. I have about 14 years experience as an evidence technician. And with that, I've also processed many crime scenes, including many with the laser scanner. So I've had to overcome a lot of obstacles in my time using the scanner, and that's where some of these ideas come from and what I've learned when I've testified in court. However, I've also picked up some very good techniques from agencies across the country that use the scanner, and so that's what this is all compiled of. I know that most of us here today either are here because we have a scanner and we want to help improve our skills. Maybe you're struggling in a certain category of scanning and you just can't seem to get it right, or maybe it's been a while since you scanned and you want to refresh your memory a little bit. And that's okay, that's great. And I know there are some of you who don't have a scanner and you're curious, or maybe you're looking to get a scanner. all of that is great. I know that there's an agency that just got their scanners, and the scanners just got unboxed, and they're here today to try to figure out, okay, now what do we do with it? So I love having that nice variety. So don't be afraid to ask questions, because if you're thinking it, probably somebody else is too, and that's the best way to address it. Okay, so we should have the poll questions about answers. So before we get started today, we will present to you suggestions. These suggestions and best practices are compiled from law enforcement agencies across America, and also from not only my experience, but the experience of my colleagues. But I want you to understand these are not the only methods. There are, multiple ways to do things, and what works best for me may not work best for you. So make sure that you're referring to your own agency's policies and procedures, and also to your court venue when you decide what to implement. The first thing we want to talk about is creating a plan. We don't want to just take that scanner and just run into the scene with it and just kind of willy-nilly hop it around the scene and hope we get something good. We want to go in there with a plan so that we know when we're done that we're going to have a great preservation of that scene. Because why is it that we preserve that scene, right? We preserve it because we want to present it in court, and also because we could be asked to put it back in place at a later date. So we need those very precise measurements. So we need a plan to do this. And often, we're under so many time constraints when we get to a scene. We may have, overtime issues, manpower issues. There may be more scenes waiting for you depending on where you work. It's really hard to find that balance between the best quality of a scan I can get and all these time constraints that I have to deal with on my job. And those are some serious factors that go into how do we create a plan? How do we scan? Because I'll tell you, in a perfect world, the scanner could document everything to the high detail extent that you wouldn't be able to know that you weren't in a real world. But we don't always have that kind of time. So we have to look for that balance. And the way we do that is creating a plan by starting with a walkthrough. We want you to walk through your scene. When you first go to your scene, you do a walkthrough to get your game plan together. I know as a crime scene investigator for many years, I would do a walkthrough where I look to see, what do I have? What's the methodology that I need to use on my crime scene? Do I need additional equipment, personnel, so on and so forth? The same thing when you get ready to scan your scene. You need to bring yourself into the scene and do another walkthrough, only this time your walkthrough needs to focus on scanner placement and what is important in my scan. One of the number one questions that I get asked when I'm visiting agencies is, when do I scan? Some agencies want to grab that scanner and use it as what we call an as you found it or in situ device. Well, that's what your crime scene photography is for. So I don't want you to do that. I want you to wait until you locate the evidence and identify it with a marker. Why do I want you to do that? Well, because that way you know exactly where everything's at in your scene, and it's very valuable to you when you're in the courtroom. Do you want the jury paying attention to you, or do you want them distracted searching for the item you're talking about because it's not identified? Now, if you were doing hand measurements, you would not run into the scene and start measuring evidence before you found it. That's kind of silly. You don't know what you want to highlight. Well, the same thing goes for scanning. You don't know what's important in your scene to document until after you've located it. I want you to map your blood stains in, identify them, and I want you to document your bullet impacts, especially if you plan on doing a forensic analysis in software such as FARO 3D, where you could do an analysis to obtain your area of origin or your area of convergence later. You're going to need to have them identified before you scan. But remember that exigent circumstances apply. If you are out on a scene and that evidence is risking contamination or destruction, by all means, please pick up that evidence as soon as possible. Don't wait to scan. You can always leave that marker in place, and then you can scan with the marker in place and add a photograph of the evidence later as an annotation in the software. But remember to look at what's most important to capture in your scene. What do I need to make sure that I get captured in the detail that I need? That's how you develop that balance between time, efficiency, and quality. So when we talk about methodical scanning, that's part of our plan. What sequence do we use for our scans? And during your walkthrough, you're going to develop this. And we're going to talk about each of these methods of methodical scanning. Line of sight, overlap, void. We're going to talk about all this in the next few slides. Ask yourself while you're doing your walkthrough, does my scene lack geometrical variations? Sometimes I get asked, well, what does geometrical variations mean? What is that geometrical pattern? Well, if you look at the photograph I have displayed here, this is a very long hallway that looks the same on both sides. There's nothing that looks different in the entire hallway. So when you look at that, you have to understand that the scanner needs to have a disruption in that geometrical variation if you plan on having the software automatically register your scans once you get into the software. So if you were in a situation like this, or maybe it's a heavily wooded forest, a cornfield, or anything that lacks a disruption to the pattern, you may want to consider adding markers, targets, or registration spheres to make your job easier, for the software to register it automatically. Remember that the scanner is 360 degrees. Keep it out of the corner of the room. Often when we see something on a tripod, we get into that photography mode because we've had some crime scene photography classes typically. And in the crime scene photography classes, it stresses to put the scanner in the corners of the room, or maybe you're outside with a house and it stresses to put your camera out on the sidewalk to get the full corner of the house. For scanners, just because it's on a tripod doesn't mean that it's a photographic camera. You need to bring that in and think 360 degrees. So you want to move it away from the corner of the room, away from those walls, so you can take full advantage of that 360 degrees, because otherwise you're cheating yourself out of 180 degrees worth of scanning. Next, we're going to talk about scanner placement. And when we talk about scanner placement, we're talking about rough sketches. I know, why do you have to do a rough sketch when you're scanning? Well, I don't need it to be, high detailed. I just need you to take a piece of paper, or do it in your mind if you have the ability, and figure out where do I need to place my scan to get the fewest scans possible, to get the overlap that I need at the time constraints that I have to work with. Because if you don't create this plan, you may find that you're doing too many scans because you forget, oh, I needed to get it over here to get this piece of evidence. Or you may miss a scan, like an important threshold scan, and now you can't connect to another room automatically. So take those into consideration and create yourself your guide or your rough sketch, so to speak. We need to make sure that in the scanner placement, we have sufficient overlap. Now, the scanner recommends greater than 30% overlap for your scans in order to automatically register in the software. A great rule of thumb is to think 50% overlap. If you can get 50% overlap, then it usually will keep you from having any issues. I'll get calls where people will say, I can't get my software to automatically register, and a good portion of the time, it's because they didn't get significant overlap. Now, be careful. You don't want to get too much overlap. There's no reason to have 98% overlap between your scans, because now you're not using your time very efficiently, and it's totally unnecessary to have all of that 100% overlap. I want to talk a little bit about photography when it comes to laser scanning. The scanner does not replace your photographs at all. You still need to be doing your crime scene photography. It is not a camera. It is a 3D laser scanner. Now, it contains a camera, but the sole purpose of that camera is to apply color to your laser data points, those measurable data points that you're collecting in your measurements. But that's only if you're scanning in color. Remember, all of your crime scene and crash scene photography rules, they all still apply here. You still need to be following your protocols to take all of those necessary photographs. You should refer to your training when it comes to those photographs. And remember, if you take those macro or close-up photographs, those are great to add into your software later at your evidence, just so that you can show that and have that nice high detailed photograph as well. It's great for courtroom presentation. And remember that you should always take your photographs as the scene was found before you do anything, and also your evidence establishing photographs. That is all in addition to your scanning. Identify your evidence before you scan. Sometimes we get in that rush to preserve the scene, and we forget to do that, or we'll scan first. And I've been asked, well, what happens if I identified my evidence and I scan, and then I find another piece of evidence? Well, my recommendation there would be to take a close-up photograph and add that photograph as an annotation into the software at a later date. The most beneficial use of the scanner is taking it at this point in time so that you can use it as a wonderful courtroom presentation tool. Imagine taking your jury to a virtual world and immersing them into that scene as you found it on that day, highlighting all those valuable pieces of evidence. Your evidence measurements are easy to obtain right in the software should you need to, and easily able to find them. I'll tell you, when you're on the stand and you're asked to find a piece of evidence, sometimes it can be challenging for you when you're nervous and you're sitting there and you're trying to find that in your scene. It's so much easier when you have some sort of identification marker, such as what we have here. Notice the overall photograph of the scene. There is a firearm at placard 2 that is on the opposite side of the table. Now, had you not marked this, or had I not marked this with a placard prior to scanning this, it would be difficult to draw the jury's attention to the firearm on the ground behind the table. Please make sure that you refrain from using any kind of chalk or spray paint when it comes to the evidence that you're seeing. Leave that for, CSI TV shows. We don't want to add that, because when we add some sort of paint or chalk, and I know that sometimes we want to, because it's just so easy to just get that evidence marked. The problem is it creates this cloud. Like chalk, for example, creates a cloud of dust. Spray paint can create a cloud of paint, and it's very misty, and you may not notice it, but it can be enough to affect DNA evidence if it's there. So you don't want to do that. You always want to use some sort of marker or sticker, and not on your evidence, of course. You always want to place it in proximity, but not on it. Remember, DNA rules do apply, and you have to follow DNA rules. So don't do anything that's going to contaminate your evidence. If you've ever had a scene with reflective objects, you may have had a chance to work through some of the challenges that come with the reflective objects. But if you have reflective surfaces and you haven't, there are some things that will, and you haven't worked through it, there are some things that will help you. There are some additional considerations. Reflective surfaces can affect the quality of your laser scanning, including things like, well, what you see here, the shiny chrome metal, mirrors, windows, sometimes bright sunlight coming through the window. Snow-covered ground. If you live in an area where you get snow, you know how bright that snow can be. Or maybe it's a freshly washed car on a bright sunny day, but you get the idea, things like that. Well, one thing you could do if you had a mirror, for example, you could take craft paper and you could tape it over the mirror so that you didn't have that reflecting issue. If you are scanning in a controlled environment and you've already collected the evidence near the surface that's reflective, a great technique to use so that you don't have to take the time putting up the craft paper and you don't have the craft paper in your finished product, a great technique to use would be something like dry shampoo or foot powder. Now, a light puff is enough. Don't coat it and go, look at this coating all over this mirror. You don't want to coat it. It should be just enough to kill the reflection, but not enough for it to be obvious that it's on the surface. A great time to apply this method, if you're going to use it, is when you're doing that planning walkthrough for your scanner. Because then any kind of little cloud or powdery cloud that may form when you apply that will have a chance to settle before you bring the scanner in there. You don't want to do it when you're there with the scanner and ready to scan. But make sure if you use this technique, all DNA or fingerprint type evidence in that area is collected first. You don't want to apply this technique if that is not the case. Make sure you find your starting point for each individual scan. And what I mean by starting point is when your scanner takes that scan and completes it, it's going to lay that out on your scanning computer screen, on your scanner computer screen. It has to lay it out flat for you to look at it so that you can make sure that you captured what you wanted to capture in that scan. When you place your scanner to start the scan, you want to make sure that where that split is for the sphere, where it lays it out flat, is not in an area of something of utmost importance. It should always be in the area of least importance. So you see here there's a yellow arrow pointing up to the top of my scanner. If I am facing the computer on the scanner, the tip of that yellow arrow represents the direct left of me, which is that 0-360 point where it breaks and lays that scan flat. That area should be aimed at the item of least importance. And the reason for that is, well, it looks a little awkward when you split a body in half or a vehicle in half. So we kind of don't want to do that if we can avoid it. Make sure you're restricting access to your scene. Keep people from moving in and out of your scene and around your scene if at all possible. This will save you a lot of work later on down the road. But if you don't have complete control of your scene and your scanner has the ability to use the retaking pictures function, make sure you have that activated so that you can retake photographs before finalizing the scan if somebody walked through your scene. Avoid getting elongated data points, if at all possible, on the things that are of utmost importance. Now, elongated data points are created when the scanner is at the same level as your item of importance. For example, if your item of importance is on the countertop and your scanner is at the height of the countertop, it's going to create very elongated data when the laser goes out and returns back to the scanner. This can create a little bit of noise. So you want to make sure that the tripod is above the area of most importance. So if I'm not concerned with what's on top of the refrigerator that's in the kitchen, I'm not going to get the scanner head above the refrigerator. But if I'm concerned about what's on the countertop, I want to make sure that that scanner head is above the countertop so that I get a nice clean point coming down on those countertops. Now, we should be adjusting this tripod between scans as we need it. Sometimes we don't always have to adjust it, but we should have that in the back of our mind so that we can adjust it when we need to do so. Underneath this scanner is a diameter of a void. The scanner can't see underneath it where the tripod is. Now, I'm not going to bore you with a calculation of exactly how to know the specifics on what the diameter is under there, but a great rule of thumb for you to just gauge it as you go, is whatever the height of your scanner is from that mirror to the ground is going to be the diameter of the surface. So here you'll see that the scanner is 3 foot high. That means my diameter is going to be 3 feet underneath that scanner. And when I was a new scanner operator, I used to take a tape measure. Hey, my scanner's 4 feet high, my diameter underneath is 2 feet, to make sure that I knew where that void was until I could gauge it just automatically by seeing it. It took a little bit of practice. But the reason for that is if you get it too close to your item of interest, it's going to be in the void and you won't get it scanned in. And you want to make sure that you don't do that. And sometimes we have to navigate small spaces. Sometimes that small bathroom, those little ones where, you can use the toilet and wash your hands and take a shower all at the same time, and you can't leave it on the tripod. If you can leave it on the tripod and just shrink it down, that's great. But sometimes that's not possible. Maybe there's evidence on that small little floor that you need. How are you going to scan it in? Well, you can always take it off of the tripod. Don't overlook that. Sometimes that just never crosses our mind, and there's probably 15 of you out there going, wow, I didn't think about that. But you want to take it off of the tripod and put it on the surface that best suits your needs. And in this case, I have it sitting on a bathroom countertop, but there's been times I've put it on a bookshelf because I needed to get blood stains up underneath the bookshelf, or I put it under a table, and the table was sitting too low for me to use a tripod. Whatever the case may be, you can do that. But if you are going to, you need to make sure that you are protecting that quick connect. Put it on something you bring with you. A piece of painted wood, a piece of tile, or you can cover the quick connect with a latex or nitrile glove, but just make sure that it's sitting flat and not sitting on the fingers and all bumpy, because you need it to be on a solid flat surface. That surface that you have it on shouldn't be something like a mattress. It should be something solid, like a countertop. And make sure there's no obstructions. That scanner needs to rotate. Remember, it's got to rotate horizontally around, so it needs to make sure that it doesn't bump anything while it rotates. And we're wrapping up our section on the placement. I want to talk about validation scales. Some of you may have a validation scale that you work. If you intend on using this in court, which I'm assuming everyone intends on using it in court, if this was a 2D diagram that you were just taking hand measurements from, and you were going to go back and draw a nice diagram, you'd be required in court to put the words "not to scale" on the diagram. Or you would have to take the time and effort to scale that diagram and put a scale in there. The same rules apply to 3D diagrams. It's still a diagram of measurements. It's in a 3D world, but it still serves the purpose of measuring your scene and measuring your evidence. You need to have a validation scale. But we're not going to spend the time scanning this scene and then come back and say it's not to scale, so we've got to figure out how to put the validation scale in there. And there are ways that we can do this. We can do this in a 3D world by placing it in the scene when we're scanning, when we're taking our scans. And we also can take a known measurement. But remember, if you do a known measurement, now you're introducing human error. There is on your screen from left to right 3 types that are commonly used for validation scales. And that's the scale bar from FARO. And in the middle is a pocket rod that pulls out of the plastic container so that it lays flat, and also a yardstick. Just remember, if you're using something that is not NIST or NIST certified, be prepared to articulate that in court. Just make sure you don't use anything that is made out of material or something stretchable or something that it's difficult to get it to lay taut when you put it down. Make sure that you're kind of sticking it out of the way. You don't want to at all put this in like the middle of all of your evidence, or you don't want to put it down in the middle of a volume blood stain. You want to move it off to the side to where you know where it's at, but maybe it doesn't draw the attention of your jury. You can do it horizontal or vertical. The FARO scale bar, as you see, does it at a nice angle with a couple of spheres to make sure that you get the exact point, because you're going to want to practice measuring your scale bar in case you're asked to do it in court, and maybe even do the measurement before court so that you can display it. Now, there are a lot of rules of thought when considering where to place your validation scale. Remember, you need to find it in court. So you're going to want to make sure that it's big enough to find it in court. Don't use a little sticky 3-inch scale and say, that's my validation scale. I recommend at least 3 feet. Up to 6 feet. I can't see why you'd want to go more than 6 feet. But that is a nice area of being able to find it, let's say. Now, some recommend that you place your scale bar in every scanner. And so you would move it when you moved your scanner. My recommendation is that you have it at least in one scan. One complete measurement in one scan. Now, it doesn't hurt to add more if you choose to add more. I know some subscribe to putting it in the first scan and putting it in the last scan. There's no set rule. You just need to be prepared to measure and validate that data if you're asked to do so. Now, the bigger the scene, the more scale bars you may need, or the more validation scales you may need. For example, if you have a colonial home, you may need to have one on the first floor and the second floor, or you may need to have one inside and outside if you're also scanning outside where something additionally took place. If you have a huge outdoor scene, you may find that you need more than one. My recommendation would not be to move the scale around, but if you're using something like a yardstick or a pocket rod, would be to have multiple, 2 or 3. If you're using the scale bar and you choose to move it around in your scene, just make sure that you wipe the legs when you move them. We're going to talk about threshold scanning. Threshold scanning is commonly referred to as the connecting scan between rooms or between inside and outside. Remember, you want your project, when you're done, this scanning project should be true and accurate for the scene as it was on that day. It's not necessarily as you found it because you've processed it and you've identified it. If you're scanning in a structure and the doors are closed, but yet you have outside evidence, it's better to leave the door closed so that it is true and accurate for what it was on that day. You would scan the inside, let's say, and then when you want to go outside, you're going to open the door and you're going to want to do a threshold scan in the door to connect the inside to the outside so that the scanner knows how the inside and the outside relate to each other when it goes into the software, so that that data is able to be registered together and connected. Threshold scanning will allow you to scan the interior of a structure in a desired high resolution and high quality setting. And the door is closed. Open the door, scan it in the threshold. When I say in the threshold, right in that door frame. Just put it right in that door frame. But change your settings. I prefer very low resolution, like a 1/10 at least. Now, if you are someone who can't remember very well to change that back, you're better off to just leave it and just do an extra scan there. But understand, you'll have both an open door and a closed door, so you'll need to do some cleaning up in the software. But if you can remember to change your settings, get into that habit, you can take the color off or reduce your resolution, do a very, very low resolution grayscale scan to connect those 2 areas, then close the door, step outside, reset your settings to what you need for those scans outside, which most likely are going to be different than the indoor settings anyway, and continue with your high resolution and high quality scans. This scanning technique can also work for threshold scans if it's in a doorway. It doesn't have to be a door. It can be doorway of maybe a garage door going out to a driveway, and in the garage it's darker, but the garage door is open, and maybe outside of the garage in the driveway it's very bright. That threshold scan can connect those. So when you think about threshold scans, they can do a lot more than just your basic door. If you're scanning the inside and outside of a vehicle, a threshold scan is needed in the doorway. Open the door of the vehicle, do a scan right in the threshold of the vehicle to connect the inside and outside. Now, only one threshold scan is needed, but don't think that you need to just do one. If you feel more comfortable doing two, front door, rear door, that works great too. So properly place your scanner positions adjoining your rooms and your hallways to obtain enough overlap. Now, even if your door is open, sometimes you need a threshold scan because based on your scanner placement, you're not going to be able to get enough overlap. So anything that you need to get you enough overlap. And lastly, scanning bodies, vehicles, and hidden objects. Scan bodies and vehicles before they're moved. Then repeat a scan in the same location after they've been moved. Not only does this help you scan the negatives, like maybe there's nothing underneath it, but if you need to put that vehicle or that body into a clipping box and hide it, as sometimes it's required by court, then you have a surface and not a black hole. Also, if you have an object hidden under a bed, you can remove that item from the area and rescan the room, which exposes that item. For example, I'm going to scan the bedroom with the bed in place, so the living room with the sofa in place. Then I'm going to remove them out of the area, and I'm going to rescan. And when I rescan, I'm going to show what was under that bed or that sofa, which could be a valuable piece of evidence. And then I'll have both. So now we are going to work on showing you some videos. And the videos are going to be a fly-through video of the woods. And the interesting thing I want you to look at here is how this is a consistent geometrical pattern. And this is a great example of where you would need to probably use some spheres. And you can see there that in using those spheres, you can see where it breaks up that geometrical pattern. The next topic we're going to get into is scanning indoor, outdoor, and in poor lighting conditions. So we have scan resolution guidelines for outdoor versus indoor scanning. When it comes to scanning indoors and outdoors, if we're scanning in a smaller space, a lower resolution can be used since there will be significant overlap. When we're in these small areas, especially crime scene, we tend to overlap quite a bit. So we have the benefit of using this small, lesser resolution or lower resolution. When scanning outdoors or in larger areas, we want to increase that resolution because we tend to space our scanning positions further apart. We don't get as much overlap. So when we don't have as much overlap, because the scene is larger, so those resolution settings need to be much higher. So the further apart your scan positions are, the higher that resolution needs to be, because your data points will be further apart. As you see here, the scanning guidelines will help you decide what best fits your needs. We also need to look at our quality settings. If we have optimal conditions, overcast lighting, 3 times may be plenty. But if we have some issues with sunny conditions or inclement weather, we may need to increase that quality to maybe a 4 times. When it comes to metering, we need to understand that metering of your scanner, the same rules apply as with your photography. So as crime scene investigators, we typically receive some sort of training in metering with our cameras. Even weighted, horizon weighted, and zenith weighted are the 3 types that we need to consider. Even weighted is ideal if your lighting is relatively uniform. Horizon weighted is best for great overhead lighting. And zenith weighting is best for scenes from eye level and below, because the camera uses light from the horizontal level. Here you have an example of scanning in poor lighting conditions. There was little or no light available in this room after a fire. And that's actually very common. When you have a fire, you have a lot of black and charring. So if you can't resolve your metering issues, such as in this case, maybe it's a complicated situation. Maybe you're in complete darkness. You don't have any lighting. Remember, you can scan in grayscale, which is infrared. So your infrared rules are going to apply. So if you're scanning blood, that's a factor to take into consideration what your surface is that the blood is on. But if you scan in grayscale, which means no color, you can scan in complete darkness and obtain a very nice scan project, just like we have here. The same room, the same setting, only scanned in grayscale. Not only can you see the details, but you can even see the chart patterns, which are great for fire investigators. When you're scanning in poor lighting conditions, and maybe you didn't realize that you had such challenges to your lighting, then you didn't set the proper settings. All is not lost. When you get to the software, you can use laser illuminated HDR, which combines your photograph of a scanned area with the information and the amount of laser light that was reflected from the surface. So if you notice the photograph on the left, you will see that we have an overexposed area in the window. We also have an underexposed area that's to the right, and this is a metering issue. And in the software, we use the illuminated HDR, which combine the grayscale and the color photograph and help to resolve that issue for a better product. If you're scanning in poor lighting conditions, understand that you can use laser HDR. HDR is high dynamic range. It's to set that greater dynamic range of luminosity or quality. It's basically bracketing. Bracketing is a method of taking several pictures at different camera settings automatically and in a methodical manner without the photographer stopping and making manual adjustments for each picture. Bracketing 2 or 3 stops down and 2 or 3 stops up adjusts your camera speed, which means you're moving 2 or 3 steps brighter and darker so you get the perfect light. Well, the scanner has an indoor HDR mode and an outdoor HDR mode. It also has an object HDR mode. This is only applicable if you're scanning using the color applied setting, but it's great to assist you with your light variances. In this example, we scanned with very poor lighting conditions without laser HDR. The next is the same exact setting in HDR mode, so you can see the difference that we have. Adaptive scanning is when you combine using the grayscale on your large outdoor scenes or your large indoor scenes and combining it with color. So for example, I have a colonial home and all of my evidence is up on the 2nd floor. I want to document the whole house. I can do that when I scan in grayscale the whole house and only scan in color for the part that contains my evidence. The same with outside. I can scan an intersection in grayscale if it needs to be documented, and to the left of the intersection you'll see in this photograph is where my incident occurred, and I can scan that in color. This saves a lot of time, still gives us the quality that we need, and it makes sure that we capture the detail we need where it is most important. And moving on to high detailed scanning, there are some times that we need to document, maybe it's trajectory rods, maybe it's blood stain because we're going to do an analysis, or maybe it's a point of impact on the vehicle. When scanning these, when you come to that area, make sure you're using your 1/4 resolution and 4 times quality at a minimum. If you're using trajectory rods without spheres, you'll want to make sure that you are at a 90-degree angle for the rods. You'll want to make sure that we are. The other thing that you'll want to consider is doing clusters to the overall scan. Now, I apologize, I had a couple of videos to show you, but due to the time running out, I'm going to skip those videos and I'm going to move on and show you a little bit of doing your forensic analysis. Consider adding clusters to your scan to reduce your time taking these high detailed scans. If you don't know how to add a cluster, reach out to me and I'll send you some step-by-step guides, or reach out to your local account manager. They'll be happy to show you how to do that. And we're going to wrap up with documenting and scanning bullet impacts and bloodstain patterns. If you have bullet impacts that you have to analyze, make sure that you identify them, label them in accordance to your policies and procedures. Make sure that you understand shooting incident reconstruction rules apply, so insert trajectory rods in the ones that are applicable. If you have spheres, use the spheres. They're more forgiving in the scanning. You can scan these in grayscale or color. There is no preference, whatever your time allows. And you can bring it into the FARO software, use the shooting trajectory tool, and determine the most common answer. Where was the muzzle of the gun when the gun was fired? Or where was your shooter? Was the shooter moving? Or did we have multiple shooters? So it gives you a flight path of that bullet. And the nice thing about that is it generates a report that gives you the exact location, your error cone, how far your slope length had to go. And this report can be given to an expert to analyze should you need an expert to testify. In documenting blood stains, we want to identify those stains for analysis. We only use the spatter stains at this time. We want to map those stains in accordance with our policies and procedures, and blood stain pattern analysis rules apply. Identify the blood stains within the pattern and mark those blood stains. And then we want to scan these. Now, I prefer you scan these in color. Depending on your surface, scanning in infrared, remember, blood acts differently, so you need to make sure if you're going to scan in grayscale that you check to make sure that the blood does appear in your scan, depending on your surface. You'll want to place 2 horizontal markers on the outer edges of the bloodstain patterns, and if your bloodstain patterns are large, shrink them down and use multiple markers. I can throw an extra marker in the middle if I need to here of my bloodstain, or I can even grid it off. But each photograph that you take needs to have what you see here, a marker on the left and right side at a minimum. So you'll need this. Make sure that you take a good photograph, get it off of auto, use manual, get it in focus, so focus on the blood stain itself and not on the wall or the sticker. And take some good 90-degree photographs. Don't have it at an angle. Make sure you fill the frame. Scan it in the 1/4 resolution, 4 times minimum. You can bring that into the FARO software. And when you bring that into the FARO software, it can provide you with the area of convergence, which is your 2D location, and your area of origin, which is your 3D location, and can assist you in determining if the victim was maybe static or ambulatory, or was the victim sitting, standing, or lying down. This also generates a report, and all of it can be validated. And there are validation reports in the FARO software under FARO Assist that you can click on. But this can also be printed and sent to an expert to analyze if it's needed to do so. So in summary, if you are an experienced scanner operator, please share your knowledge with others. You're only as valuable as the knowledge that you share, because one day that person standing beside you will be the one picking up the scanner and scanning and not you. Don't become stagnant. Technology is always training. I get it's a challenge to keep up, but there's free training, there's online videos, there's knowledge.faro.com, there's user groups, workshops. get a hold of your account manager and ask him, hey, is there a user group going on somewhere? Connect with your other agencies, hold your own, attend workshops, attend FARO Live, FARO Knowledge Base, and most importantly, practice. Practice, practice, practice. Go to some mock scenes, make them yourself, and scan these mock scenes. But do what you need to do. So in wrap up, I know that we've got a video or two to play, and I believe Dean is going to address some questions. I can hear you now. Thank you.
Excellent. Okay, wonderful. Brenda, I am so glad that we are recording this presentation because so much of the information that you've shared with us today, I just wasn't able to write it down fast enough. Lots of good stuff. Thank you for that. But we do have several questions and not a whole lot of time to get to them. So I'm going to go ahead and get my first question from Abby off to you. His first question is, any reason that we do not have a filter for mirror or reflective surfaces?
I would have to refer that to the designers of the equipment, but I would have to say that most likely it's because an adjustment in your quality setting does make adjustments for some reflective surfaces. Mirrors, because the laser is going to strike the mirror and reflect off the mirror, any setting that you do is not going to counter that. A mirror is always going to reflect no matter what.
That was really interesting, that comment that you made about the powder and those types of things. That is just something that a standard person like me wouldn't consider. It seems like that might create a little bit of a problem evidentiary-wise, but I think you address that with telling the users to make sure they get that done well in advance, right?
Absolutely. You wouldn't want to apply that technique if you had forensic evidence there. Not at all. But it's just one in many solutions. You can just use a higher quality or even scan in grayscale if you don't want to apply that.
Excellent. Good. Eric asked an interesting question as well. He asked, is a validation scale needed if my certification of my scanner is within calibration?
Yes. We have to always put a validation scale in there because that's what the courts require, because it is a diagram for the purpose of measurements, and anything you're using for measurements needs to have a way to validate or verify that the measurements on that specific project is accurate. Even in your software, it will give you a standard deviation for that specific project.
Excellent. A couple from Cameron, who asks a two-part question. One, what was the recommended overlap on the scans? And two, when you were on your tripod height and void slide, he asked, is that a true representation, that 3-foot void area underneath the scanner? Cameron, I hope that I'm accurately characterizing your question.
Yes, so it is greater than 30% is what's needed. We recommend 50% overlap for crime scene scanning, but greater than 30% is all you're required to have. As far as for your scanning height, what I gave you was a guide or a rule of thumb to go by. If your scanner is 3 foot from the surface it's on to the mirror, then you will have an average of a 3-foot diameter underneath coming from the center of the scanner. So it'd be 1.5 foot out in each direction. That's not exact. There is an exact calculation that I can give you if you want it, but that's just a simple way to eyeball it.
So often in the field, Brenda, we need to rely on these rules of thumb, right? Obviously, we're always going to err on the side of caution, but those rules of thumb are very handy, aren't they?
They are, yes. It's like a quick reference.
All right, good. Couple more quick questions, folks. Thank you for your patience. We want to make sure we take advantage of Brenda's experience while she's here. And as a point of personal privilege, Brenda, I had to ask this question about scanner height. Is it recommended to adjust the scanner height? Say, for example, we're in a flat surface, all things are level. Should we stagger the height of our scanner to get the best coverage?
If you're on a flat surface and all things are level, it's not required. It doesn't hurt as long as you are staying at a height above the surface of interest for that specific scan, or maybe down below it. For example, I want to get closer to the floor and have my scan point up. You don't necessarily have to be above it. Just avoid that elongated scanning for what's important.
Excellent. Very good. Now, we've got way more than 2 questions, but in the interest of time, I'm going to ask 2 more. So thank you, everybody, for your patience. And the next question comes from Christopher McIntyre, who asked, if you have minimal light in a fire scene, say a small LED light in a room, is grayscale scanning going to be the way to go, or should a different setting be used?
Answer your question, Dean. So if you have a little bit of light, like in a fire scene, for example, I actually recommend, if you are in a very poorly lit or dark area, I know you're going to bring in lights to be able to process that scene, but I recommend when you scan, turn them off. If you can't remove them completely or you don't want to remove them completely, at least turn them off and just scan in grayscale. I love the way grayscale shows detail, especially on fire scenes. If you scan in color, all is not lost, because you can always just say, I don't want to use the color, but I do recommend grayscale.
Excellent. Christopher, we hope that answers your question. And the last question, again, I'm going to go to one of my fellow Canucks here, Brenda. Abby, again, in Ontario, asks, would you be able to touch on scanning in rain and snow? For example, in Canada, we've got some very cold conditions, and I know that it varies from scanner model to scanner model, but is there an area where we could perhaps send Abby or other customers to get information on scanning in inclement weather?
Yes, I know that YouTube has videos. FARO Academy has a lot of information. They can also learn about it through knowledge base when it goes over those. And of course, Dean, I'm sure you probably have some classes that would be beneficial to them as well. But I have scanned in some pretty hefty snowstorms, and most recently scanned in a pretty heavy rainstorm. And as long as it's not like completely, a blanket, I guess you could say, of snow, it shouldn't be a problem to you. Where snow might create a problem is taking the photograph. So if it's snowing that hard, grayscale is your way to go there most likely, so that you don't get white spots on the surface of where the data was. Because remember, the color is used to apply to those data points. For rain, I haven't seen it be much of a problem. I've increased my quality during rain to give me a better quality to my scan, but sometimes you just might see a little noise in your scan. But if you are concerned, just don't apply color and scan at grayscale.
Just piggybacking off of that, dealing with precipitation, specifically rain, do you find in your experience, Brenda, that rain adds to the reflectivity of surfaces, say a car in an outdoor environment?
It could, but I haven't seen that. I mean, I actually have a project done by an agency that was done in like severe tropical storm kind of weather, and it didn't bother the scene much at all. They scanned in color, and it really did not bother the scene much at all, but they used a higher quality on it.
Excellent. Well, you know what? I think that we're going to bring the presentation to a close. We want to thank all of our attendees here today. Brenda, really good stuff today. Thank you for sharing your experience and your insights. I have a feeling, ma'am, based on the response to this webinar, that we might be tapping you on the shoulder to do it again in the future. Would you be up to that?
Sure. And if there's more questions, I can answer them through email afterwards.
Excellent. Wonderful. To our attendees in the audience, we will be contacting you post-webinar. All the folks that registered will be sending you links to recordings and those types of things. And, of course, we'll provide further contact information as well if FARO Technologies, experts like Brenda or others might be of further assistance. On behalf of everybody at FARO Technologies, we'd like to thank you for your time and attention today, and we look forward to seeing you at our very next webinar from FARO Technologies. Have a good day, everybody.